So today I want to talk about seeing if a function is continuous at a certain point on x, when x equals a certain number. So let's look at this example. So you're going to let the function of x equal these, alright? It's not just one, it's three different sets, alright? So it equals x squared minus 4 over x squared minus 5x plus 6 only if x is not equal to 2 or 3. And the function fx also equals negative 4 if x equals 2. And the function of x also equals 10 if x equals 3. So let's look at the first part. Well, there's just two different problems, but we're looking at this part, the first part. So these questions will be on the AP test, and it's not about finding the right answer to the question. It's about showing how you find your problem. So on the AP test, you'll be marked down points if you don't show or show how you get your answer. So first off, the first point we want to get, the first point we get. So in order to get the first point, we gotta write like our thesis. So we're gonna write if f of x, if f is continuous at x equals 2, then the limit as x approaches 2 of f of x equals f of 2. Sorry for the mistakes. It's kind of hard to record while holding a camera. Well, anyways, so in so we plug in. So look at this, the 2, right? So that'll equal 2. So when the x equals a 2, it equals a negative 4. Therefore, when the limit as x approaches 2 of f of x equals f of 2, so f of 2 equals negative 4. So the limit as x approaches 2 equals negative 4. So for this part of the question, you get 1 point. 1 point on the AP test. You need that 1 point. If you don't have this, you won't get that 1 point. So now you want to prove. So in order to see if f is continuous at x equals 2, we're gonna want to see both sides of the equation. So we're gonna show to get another part of the point for the AP test. We're gonna show how we worked out and how we found the answer. So we're gonna find the both sides. So limit as x approaches 2 from the left of f of x equals so let's see. F of x is 2 from the left. What's 2 from the left? 2 from the left is 1.9999999, and 1.99999 is not equal to 2. Is not equal to 2. Is not equal to 3. Therefore, we have to use this function. All right. So you're going to want to put x squared minus 4 over x squared minus 5x plus 6. Alright? Okay. So then we're going to find the right side also. The limit as x approaches 2 from the right of f of x equals same thing. From the right side, it's 2.000001. So it's not equal to 2 or it's not equal to 3 as well. So you're gonna want to put the same equation, x squared minus 4 over x squared minus 5x plus 6, and then you want to find 2 also exactly at the point of 2. So x equals to 2 of f of x equals, and since it's exactly at 2, the function of the limit would equal -4, so it's automatically -4, which we already proved here, so it's already like that. So now we want to factor. When you see a problem like this, you're going to want to factor it to make it easier. So how do you factor this? So it's x squared minus 4 over x squared minus 5x plus 6. This factors into x minus 2 and x plus 2, because x times x is x squared, and just equals that, and then x and it factors into x minus 3 x plus 2. So negative, wait, let me check this real quick. X squared is x squared, 2x minus 3. Oh wait, oops, I made a mistake, sorry. X minus 2. Oh, it's x minus 2. So these cross out, and what you're left with is x plus 2 over x minus 3. So now we can change these into that. So it's x plus 2 over x minus 3, x plus 2, x minus 3. So now, since they're basically almost the same, we can just plug in the 2 automatically instead of 1.999 or 2.001. So 2 plus 2 is 4. 2 minus 3. 2 plus 2 is 4. 2 minus 3 is -1. Same thing. 4, -1, which equals -4, -4. All these are the same. Alright? Now you get 1 point on the AP test for showing your answer, for showing how you worked out your problem. So far, now, since these are the same, -4 equals -4. So that means it's continuous. Now you want to write the conclusion. So we're gonna write therefore f of x is continuous at x equals 2, and that's another point on the AP test. And now we got 3 points on the AP test, which you'll need. So if you just got your answer, you will be losing 2 points, because you won't be showing your work or showing the conclusion. So you want to show all of this in order to get all the points on the AP test. Now let's try another one. Is this the second part of the first question? So we're going to use the same one, but for this problem. So what we want to write first is, if f of x is continuous at x equals 3, then the limit of x approaches 3 of f of x equals, so 3, what does 3 equal? 3 equals 10. So it will be f of 3, which is equal to 10. Okay, so now we want to show, that's 1 point. Okay, that's 1 point. Now we want to show how we get our answer. So the limit, I'm going to speed up a bit. So the limit as x approaches 3 plus of f of x, the limit of x approaches 3 from the left of f of x, and then we already know 3. We already know what 3 equals. 3 equals 10. So when 3 doesn't equal, when f of x doesn't equal 2 or 3, we have to use this equation. So this equals, and since we already kind of, if you don't want to, we're being timed on the AP test as well. So since you already figured out how this is already factored from the first one, we can already assume that this so that already this equation equals x plus 2 over x minus 3. So we're going to put, instead of doing the whole work, we can just skip to x minus 2 over x plus 2 over x minus 3 equals x plus 2 over x minus 3. So when you plug in the 3, what are you going to get? 3 plus 2 is 5. 3 minus 3 is 0. Same thing. And when you divide a number, when a number is divided by 0, it does not exist. So D and E. Okay. So it does not exist because 5 divided by 0 does not exist. 5 divided by 0 does not exist. And since we're approaching 3 from the right side, it would be positive infinity. So it would just be infinity, right? And then since we're approaching 3 from the left, it would be negative infinity. Damn it. Okay. Negative infinity. Alright? So infinity, negative infinity, and 10 do not exist. So basically, since positive infinity, negative infinity, it equals D and E. Does not exist. So does not exist. Does not exist does not equal 10. So now we get another point for showing our work, and we just solved and showed that x that at the point as x equals 3 is not continuous. So the function as x equals 3 is not continuous. So we're going to write the conclusion. Therefore as f of x is not continuous at x equals 3. And you get one more point for that. So in total you get 3 points. So you want to show your thesis, show how you solve the work, and show the conclusion. If you just got your answer, you only get 1 point, which you'll be missing 2 points on the AP test, which is a lot of points, and you probably failed the AP test. So you want to show all your work. So that's how you find if a problem is continuous.